Hey guys, welcome back. We're looking at quartic functions now. They're polynomials which has a degree of 4, meaning the highest, I guess, power in one of its terms is power of 4. So this could look like y equals x to the power of 4, or you could have a factorized form of something like this. Okay, and again, just as I shared with cubic functions, in factorized form, we'll have our x solutions using our just using the null factor law. X solutions are going to be -1, +2, -4, +3. Okay, and then you could work out your x-intercepts there. Obviously, with the quartic functions, you're not always going to have 4 x-intercepts. You might have 3, 2, 1. It really depends on where it lies and what the function is. And so just on the left, we have some really, I guess, quick illustrations of some options of what quartic functions can look like. Some can resemble similar to a parabola, and some a little bit differently as well. And so you could have a look on the left and see the different variations there. Obviously, if a, which is the coefficient of x to the power 4, if that value is negative, you're going to have it in inverted function. Okay, so similar to any parabola, if x squared is negative, then it's an upside down or inverted parabola. If you're going to have something the same thing with cubic functions or quartic functions, basically everything's inverted if a is negative. So the quick rule of thumb here is that you would want to work out your x-intercepts by factorizing the polynomial, and that's going to be, I guess you could look at the factor theorem, finding out solutions, and going from there. So we'll go through an example now. So first thing, you want to get your y-intercept. Second thing, you want to get your x-intercepts, and then we can go from there. All right, so y-intercept here, obviously when x equals 0, and if that's the case, if we substitute x to 0, that term goes out, all of these terms goes out, and we have 12 being our y-intercept. So y-intercept is equal to 12 in this case. I'll just put this here as 12. Okay, next thing we'll look at the x-intercepts, and we need to, I guess, we can always just say that p of x, or the function of x, it doesn't really matter. In this case, it's a polynomial represented as a quartic function. Okay, so we got x to the power 4 minus 2x cubed minus 7x squared plus 8x plus 12. I'm going to approach it with the factor theorem and trying to figure out, I guess, what a factor would be. So we need to work out what a factor would be by substituting x with a value. So let's start with 1. So p of 1 means 1 to the power 4 minus 2 times 1 to the power 3 minus 7 times 1 to the power 2 plus 8 times 1 plus 12. And we want this to equal 0 because if there was a remainder, then it's not a factor. So this will become 1 minus 2 minus 7 plus 8 plus 12. So this becomes just 12. So it's not a factor. Okay, so 1 does not work. Let's go up the scale with p of 2. Okay, so 2 to the power 4 minus 2 times 2 to the power 3 minus 7 times 2 to the power 2 plus 8 times 2 plus 12, and we've got 16 minus 16. Okay, so we can already say that they cancel out. so minus 28 plus 16 plus 12. Now, 16 plus 12 is 28, which cancels out with the negative 28. So that becomes 0. That means P of 2 is good. X minus 2 is a factor. Now, from this point, what you'll do is you'll divide, use long division. And you'll actually go through the whole process as what we've done in our chapter of polynomials, and work out what each of the other factors are. Okay, so you'll be breaking it down from quartic to cubic to quadratic to linear, and you'll end up getting your four factors in brackets, which will end up in this case looking like x plus 1, x minus 2, x minus 3, and then x plus 2. Once you reach this stage, then use the null factor law to get your solutions. So we got x, the solutions for x is minus 1, positive 2, positive 3, and minus 2. So now we have our X-intercepts, we have our y-intercept, and we can graph it all together now. So 12 is our y-intercept. In terms of our x-intercepts, we have minus 1 and minus 2. We have a positive 2, and we have a positive 3 as our intercepts. Now, if it's going up, I can assume that it's going to go down. Okay, so in order to go down to the 2, it's going to go like that, and then go up, and then will be the same thing going there as so. Now, in terms of turning point, again, not really phased with this at the moment. The x and y intercepts are the most important parts for this particular part. So I'm keeping it brief there. If you need to refresh your memory in terms of dividing polynomials, I suggest that you go back and check those videos out, and then you can then progress from there because you've already worked out your x-intercepts. Working out the y-intercept is fairly straightforward, and then just keying those parts in together and seeing how you join it all up. Now, if you need any help with sketching and figuring out where it starts and where it goes, please let me know. I'm happy to assist. Okay, I'll see you in the next video.